Why is stress hard to calculate for complex shapes? Have you ever wondered why calculating stress in complex shapes can be so tricky? It all comes down to how forces are distributed within materials. When we talk about stress, we mean the force applied over an area. For simple shapes like rectangles or circles, it is easier to use basic formulas because the stress distribution is more predictable. But with complex shapes, things get a lot more complicated. Complex shapes often have irregular geometries. This means that stress can vary widely at different points. For example, if you take a beam with a unique cross-section, the stress will not be the same everywhere. This makes it hard to find a single formula that accurately describes stress across the entire shape. When we calculate stress, we often refer to the neutral axis. This is an imaginary line in the cross-section where the stress is zero. In simple shapes, finding this axis is straightforward. However, in complex shapes, it can be quite challenging. To accurately determine the stress, engineers need to calculate the moment of inertia. This is a measure of how the shape resists bending. These calculations can be very detailed and often requiring advanced methods. Additionally, complex shapes experience different types of stress at the same time. You may have normal stress, which is tension or compression, and shear stress, which occurs when layers slide over each other. These stresses can interact in unexpected ways, especially if the shape has curves, holes, or varying thickness. To tackle this, engineers sometimes break down the complex shape into smaller elements. This allows them to calculate local stresses more easily. However, this process can be mathematically intensive and requires careful analysis. In practical terms, this difficulty in calculating stress means that predicting where a product might fail is not straightforward. Engineers often turn to computer simulations, such as finite element analysis. This technique divides the complex shape into many small elements and calculates the stress in each one. It helps in identifying stress concentrations, which are areas where stress is much higher than average. These are often the points where failure is most likely to begin. Understanding the challenges of calculating stress in complex shapes is essential for improving product designs. By analyzing these stress distributions, designers can make changes to reduce the risk of failure. For instance, they might add fillets to sharp corners or reinforce thinner sections to enhance durability. In summary, stress is hard to calculate for complex shapes due to irregular geometries that cause uneven stress distributions. This complexity requires advanced mathematical techniques or computational tools to accurately predict mechanical behavior and prevent product failure.